in the astronomy community of India. This year, it is being organized jointly by the WGGE ASI and the Gender Amity Cell of IAA. The Gender Amity Cell of IAA has been functioning since 2009. It aims to foster and maintain a respectful workplace environment at IAA and provides a platform for addressing and discussing gender-related issues within the institute. We are delighted to welcome Professor Sharada Srinivasan, Professor, National Institute of Advanced Studies, Bangalore, to deliver the 20th Anamni Lecture. Welcome, ma'am. To begin the program, I welcome our director, Professor Annapurni Subramanian, who has joined online to give an inaugural address. Hello, Professor Annapurni.
Yeah, sorry, I wasn't able to unmute. Yeah, no, I'm able to. Yeah, thank you. I'm sorry I've not been here there physically. So I'm very happy that we are holding that working group towards gender equity WGG's program on Namini lecture here. And I'm also very happy to welcome Professor Sharada Srinivasan to the institute. I remember, we having her for a lecture during, I think it is International Women's Day long back in this auditorium, and I welcome her back once again to this auditorium, and we look forward to listening to her. Thank you, the Gender Amity Committee of IEA for taking the initiative to hold this Anamani lecture here, and I look forward to an engaging lecture. Thank you.
Yeah. Thank you, President Annapurni. Now I welcome Aru Devi, co-chair of WGG ASI, to give an introduction to Anamani lecture series and WGG.
Greetings, everyone, and welcome to the 20th Anamani lecture at IAA. So we are pleased to hold it at IAA and welcome, ma'am. A very brief introduction to WGG, Working Group for Gender Equity, ASI. So this organization or setup was made in 2015, and so it's almost 10 years. So it could be like 10-year celebration with Sharada today. So currently we are constituting, WGG is constituted of 8 members, and Professor Payali is the chair of the WGG, and myself as co-chair and other members which are on the screen. And the primary goal of WGG is to address the gender-related issues in the Astronomical Society of India. And as part of this, we also conduct annual Anamani lectures and for gender sensitization in the community. And can I go ahead? Sorry. So thanks to Smita for briefly talking about Anamani. So this Anamani lecture is named after Dr. Anamani, and who was a pioneering Indian physicist and also meteorologist. And she has done pathbreaking research in 1950s, fighting against odds. And she was an undergrad student at the Presidency College in Madras, where she undertook her undergraduate research and then followed with an internship at IAC. And however, she was not awarded PhD degree because she did not hold a master's. So then later on, she moved to UK for doing internship at Imperial College. Later in 1948, she returned back to India and joined Indian Meteorological Department, and where she served until 1976, and also retired as a deputy director there. And later on, she joined RRI, Raman Research Institute, as a visiting professor, and where she helped in studying the ozone layer and also setting up instruments and telescopes for solar radiation studies. And she has also written 2 books on solar radiation. And so currently, I would like to very briefly discuss about the impact of WGG on the astronomical community as such. Like this habits have been going on for last 10 years. So as part of this initiatives by WGGE, now plenary on gender equity is a regular feature during the annual ASI meetings, and fraction of women speakers have increased to 30% in the annual Astronomical Society of meetings, and including childcare facilities are routine. And for further details, I would like urge you all to go through this conference proceedings, which we presented in IUCAM conference, and this paper is available on the WGG webpage. And with this, I would like to thank everyone and invite Professor Shikani.
Thank you, Arun, and welcome everybody for this event. It's really a great pleasure to have, an honor to have Professor Sharada Srinivasan, the speaker for this very special event. Actually, IAA also, IAA and IMD started from the same campus years ago. So it's very apt IAA is hosting this event. So Professor Sharada Srinivasan is one of the most distinguished archaeomaterial metallurgist. So sorry about it. It's an archaeometallurgist and a heritage scientist. She is the professor at National Institute for Advanced Studies, NIAS, in Bengaluru, where her pioneering research bridges science, archaeology, and art history. Professor Srinivasan earned her degrees in engineering physics and material science from IIT Bombay, and her PhD in archaeometallurgy from the University College of London, where she studied the South Indian bronze casting and metallurgic techniques. She researched, her research has provided groundbreaking insights into ancient Indian metallurgic tradition process, and through advanced, through her advanced methods like such as lead isotopic analysis, X-ray fluorescence, and metallography, she has made these discoveries on this chola bronze casting, which is one of the unique techniques. She has also authored several books, like one of them is the India's legendary Woods Steel, and a contributing author to Ecstasy of Classical Art. And she also is a co-editor for Digital Humpy. She has also received numerous national and international honors, including the India's fourth highest civilian award, the Padma Shri, in the year 2019 for her contribution to archaeology. She received Women Engineer of the Year in 2021 by the Indian National Academy of Engineering. She received the Dr. Kalpana Chawla Young Scientist, Women Scientist Award in 2011. INSA Medal for Young Scientists in 1999 by the Indian National Science Academy. National Award for Women Scientists by the DST. And she is a fellow of Royal Asiatic Society of Great Britain and Ireland. She's also an invited fellow of the World Academy of Art and Sciences. Beyond her scientific achievements, she is an accomplished Bharatanatyam dancer, known for her unique lecture demonstration blending art and science and cultural history. Her exploration specifically on Nataraja bronze as both a metallurgical and cosmological masterpiece is kind of exemplifies her unique interdisciplinary vision in these two areas. Today, we are really grateful and honored to have Professor Sharada Srinivasan to give the 20th Anamani lecture titled Archaeological Sciences and Archaeomaterials Research, a Gender Perspective. Thank you, ma'am.
A very good day to you. Am I audible? It's a great pleasure to be back here at the Indian Institute of Astrophysics to deliver the Anna Mani lecture for the Astronomical Society of India Gender Amity Cell. And thank you so much, Professor Shivrani, for the very kind introduction, which I don't know where all those details you picked them up. Thank you so much. And it's wonderful to be here also because when I was here last, I gave a lecture for the Women's Day, as Professor Annapurni Subramaniam mentioned. And it's very wonderful also to be here because it's a great source of pride for us that we have such an eminent woman scientist heading one of our top scientific institutions. So it's a great opportunity for me to be here today. And my talk will be on archaeological sciences and archaeomaterials research from gender perspectives. And the central picture, of course, is the celebrated Delhi Iron Pillar, which is the earliest massive iron forging in the world with a Gupta Brahmi inscription of about 400 CE. And of course, it stands testimony to the skills of the Indian subcontinent in antiquity in the area of metals and metal extraction and working and so on. And as mentioned very kindly, I also got interested in this area of archaeomaterials research because although my primary training was in engineering physics at the Indian Institute of Technology in Bombay, I also had a life as a exponent of classical Bharatanatyam. And of course, these dance traditions are also very closely linked to the sculptural traditions and so on. So I also drew a certain inspiration from that. And I should say that since there's a lot of talk on Indian knowledge systems and so on, of course, classical dance is a knowledge system in its own right. And that's why I tend to sort of gender my talks in a way also by putting in photographs of myself, at sites and so on. Maybe it is an indulgence, but for me, it is also because it represented a significant aspect of the expertise that I had. So I see no reason to separate it out and leave it discarded because, so anyway, so that's why, and since this is a talk which is essentially about a bit of a personal journey, I have put in a fair amount of some of these personal photographs and so on. And the other photograph on the far side is at the urn burial excavation of Adichanallur, and I will talk about that site more as we go along. And as you can see, it's a pit burial, and at the bottom you see a lot of these iron implements and so on. So we were trying to get our portable XRF machine down into the pit to do the analysis. And of course, speaking of the challenges and personal journeys, I had a condition which, in fact, only women get it. It's called bilateral developmental hip dysplasia. And this was despite being a Bharatanatyam dancer and so on, where the hip bones are not properly in the sockets. And so that leads to deterioration midlife much earlier than normally it would. And so I had to have a hip replacement in 2022. And I'm here at the site just 4 months after. So archaeology is not for the faint-hearted because it does involve a lot of travel to remote areas and, getting into mine sites and trenches and so on. But for those of us with an adventurous outlook, it can be a very fulfilling area and so on. And of course, as I mentioned, archaeomaterials is concerned with the study of archaeological artifacts and archaeometallurgy, in particular metallurgical aspects and mining and extraction and aspects of the history of technology and so on. Of course, this is an audience of scientists that I'm talking to, so I don't have to dwell too much on these aspects and how we can use advanced materials characterization to get a better sense of the way the artifacts were made and the provenance issues and the trajectory of the use of metals and alloys and so on. And here you see me also with the portable XRF machine and some other along the way in my earlier days with the electron probe microanalysis and so on. And the site that you're looking at, the copper mine is in Andhra Pradesh, in Agni-Gundala, and that was during my doctoral research in 1992. And you can see that it's an old copper working from the malachite stain, the greenish malachite stain of the copper ore. And I put that in talking about the challenges of remote working and so on, because not long after we took this photograph, I was there along with a person from the Hindustan Zinc uh, base, which is there in Agni-Gundala. And there was this rustling sound we heard, and we turned, and I thought it must be a rabbit or something. But no, it was a large feline, and it leapt. I think even before I could try and take a photograph or something, 40 feet it had leapt across. And I said, no, I mean, that can't be a cheetah, is it? It had spots. And the guy from Hindustan Zinc told me, yes, madam, you're right. It is a cheetah. It's not a leopard, because the Guntur district was the old habitat of the cheetahs. And this must have been one of those stray cubs, because I know the cheetahs were supposed to have been extinct, well by that time. But this was just some stray cub, and this wasn't the only time it was spotted. So this was, in fact, a cheetah sighting. But my bad luck that I couldn't actually photograph it. So I think that's what makes the contributions of women in these kinds of fields also something which is also to be noted and lauded in that sense. And coming to Anna Mani, of course, you all would know much better about her contributions, but certainly a very inspiring personality, a pioneering woman physicist and weather scientist. And of course, to me, what is also very interesting is all the work that she did in instrumentation to make different kinds of instruments to measure rainfall and temperature, and which is, I think, quite in a way rare for women to be so involved in instrument making at such an early time. And then she made the ozone sonde, which was also then used in the Antarctic expeditions. And then, of course, later there were all these finds of the ozone, the holes in the ozone layer and so on. And so she's played a big role as a climate scientist. But I should say that her lives and contributions also have a certain resonance for me in various ways. She was born in the princely state of Travancore, and her father was an engineer there. And my mother, Geeta's grandfather, was Sir C.P. Ramaswamy Iyer, who was Diwan of Travancore from about 1935. Of course, like all these historical figures, there are all these shades of gray, but there's no doubt that he spurred a lot of scientific and industrial infrastructure in his time, including dams and canals and hydroelectricity generation, such as at Pallivasal. And he also facilitated the historic Temple Entry Act on November 12, 1936, to include the marginalized lower castes in temple worship. And this is, of course, 89 years ago. And tomorrow, 12th of November, is also CP's birthday, so I thought I would mention it. And Anna Mani, who lived in those heady times, is said to have been inspired by the Vaikom Satyagraha and the temple entry movements and the Gandhian ethos. And then she only wore khadi after that. So this is a photo of CP seen at my parents' wedding with his eldest grandson in the rear, late C.V. Seshadri, my mother's brother, who's also a well-known developmental scientist, who also personally knew Anna Mani. And my aunt Premlata also recollects her well. And Anna Mani, of course, also famously worked under Sir C.V. Raman. And so this is a file photo from my parents' wedding. My father, Dr. M.R. Srinivasan, former Atomic Energy Chairman, who passed away in May this year, and my mother, Geeta, with him. And I should say, of course, talking about my personal journey as a woman in sciences, I should acknowledge the inspiration of my father, who is widely regarded as the chief architect of India's civil nuclear program, having led the design and construction of some 18 nuclear power plants. And he passed away at 95 in May this year. And he wrote a lot also on the push for self-sufficiency after the nuclear tests when the Canadian aid was withdrawn in the 70s. And the way they had to get around to making all the parts like the Calandria and so on for the Madras Power Project in his book of 2002. And also thinking of Anna Mani's own journey with the actually building instrumentation and that kind of infrastructure building, which is also, I think, a very important dimension in terms of the engineering hardware. So it's not only the pure science, but these aspects also that are very important. And I should also say that his descriptions of the nuclear fission chain reaction of the uranium-thorium cycle to generate atomic energy and the visits to the power plants, that also influenced me of course, to get into engineering physics, but also my work, which I'll talk about later, on the use of the uranium thorium geochemistry also in archaeological research, the lead isotope ratio analysis and so on. So that did stem out of some of those prior discussions with my father and so on. Well, I should say that Anamani can also be regarded as a pioneering archaeomaterials researcher also, because she did very important research on rubies and diamonds in C.V. Raman's laboratory. And of course, C.V. Raman is known for, apart from the Nobel Prize and the Raman effect in 1930, he also studied the diamond crystal lattices and the atomic vibration spectra and so on. And this also was an important dimension of Anamani's work, the fluorescence, absorption, and scattering of light in ruby. And of course, there is a very long association with diamonds and precious stones in the subcontinent, and the best known diamonds around the world in the late medieval period came from India, such as the Kohinoor, which is the largest cut diamond weighing over 100 carats, which was in Shah Jahan's Peacock Throne. And it is said to have come from Kolur mine in Andhra Pradesh, which is now part of the crown jewels. And interestingly, talking about the gender dimension, Marco Polo, the 13th century quixotic Venetian traveler to the east, also mentioned that the finest diamonds were mined under the Kakatiya queen, Rudraamba, who ruled from Warangal in that period. So it's also important to remember that women in medieval times also had agency and contributed in these areas of mining and metallurgy. And speaking of diamonds, of course, it's difficult to find a lot of early jewelry, but there is very clear early evidence for the use of diamond drilling from the megalithic site of Kodumanal in Tamil Nadu. And you're seeing here some of the cis burials and dolmens and so on at Kodumanal. And there is also a lot of evidence for the production of quartz beads, which seem to have been drilled using a diamond bore drill. And the hardness of quartz is around 7, and diamond is the hardest at 10. And the use of these kind of diamond bore drills was still seen around the Karul region, as the well-known archaeologist K. Rajan had mentioned to me. But now that's all died out, though it still goes on in the Cambay region. And as far as finds of early gold jewelry are concerned, there are some very important finds from the Nilgiri cairns, which is the Nilgiri hills flanking Karnataka and Tamil Nadu, where also there was a very, when I was young, Professor Srikantan and others were working there with a very important radio astronomy facility and so on. And some of the finds of gold jewelry, you can see that they are set with stone in the similar way that they would with Kundan jewelry for diamonds and so on. And you're also seeing a very fine example here of South Indian temple jewelry with rubies and diamonds and emeralds, the Naga or the serpent motif. Well, when we look at Indian antiquity, of course, there are many very spectacular representations of the feminine, which are very inspiring. There is a very beautiful image of Saraswati, or the goddess of learning, in the Brihadishwara temple in Tanjavur. And there is also this picture that I put in of the Jalasangvi from Karnataka, Kalyana Chalukya period of the 11th century, where you see that there's a lady scribe who's inscribing Hale Kannada on what seems to be a representation of a copperplate inscription. And next to that is a Jain image of Ambika from Karnataka, which is also, she holds a manuscript, again, associated with learning and so on. And that had also been fingerprinted by me. I don't have too much time to touch on all the objects I studied, but anyway, I will cover a few here and there. And then next to it is a very beautiful depiction of a Devi in the Freer Gallery now. And this image had been identified by the well-known art historian Ananda Kumaraswamy as possibly a portrait sculpture of the renowned 10th century Chola queen Sembian Mahadevi, who some of you may also know from the famous Ponniyin Selvan movie made by Mani Ratnam. And what is very interesting is that the reason to believe that this could actually be a portrait of Sembian Mahadevi is also that there were inscriptions of Rajendra and so on, mentioning that deified images of the queen were taken around in procession because she was a great patron, and also, there's a town in Tamil Nadu named after her, Semyan Mahadevi. And she also commemorated a lot of temples in the memory of her late husband, Gandharaditya Chola, at Koneri Rajapuram and elsewhere, because he became an ardent devotee of Shiva and fasted unto death and so on. So it's a kind of interesting example of a male muse really dedicating the temples to her husband and so on, which we associate with, for instance, Shah Jahan and the Taj and so on. And you also see that there's a commemorative plaque at the Koneri Rajapuram temple with a depiction of Gandharaditya Chola, and she also had a garden named after him and so on. So it's interesting to know of this agency that women had, although in her case she was also widowed. And the next picture is one of the female Shaiva saint Karaikal Ammayar, who is said to have lived in the 6th century. And according to legend, she became a hag as a devotee of Shiva to worship him more closely. So, but it is thought that she was actually a woman saint of that period. And this is also a bronze which I had analyzed by inductive decoupled plasma optical emission spectroscopy. It's in the Victor and Albert Museum, and it had about 20% lead and 3% tin. And it's a very interesting characterization because it also celebrates in a way the fact that beauty transcends physical appearance, because there are other kinds of beauty than rather just what is visually pleasing and so on. And just to touch upon some other aspects of patronage of monuments and art by women, we had also worked on, under the Digital Heritage Project, which I was convening also with various institutions like IIT Delhi. There was a project to undertake laser scanning of various monuments. So we had also done one of the Rani Ki Vav, and you're seeing there a photograph of a 3D printed version of the Rani Ki Vav, which is a famous step well. Again, it is attributed to 11th century Solanki queen. And the Solankis, of course, were associated with the Chalukyas of Karnataka, the lineage of the Chalukyas. And you also see that's why a similar sculpture of a sleeping Vishnu, which is also, if you all have been to Badami and the other Chalukyan sites, you would have seen a similar kind of depiction of the Vishnu, Seshashayi, and so on. And other famous examples of patronage, there is the Mughal era Itmat-ud-Daula, which was built by Nur Jahan for her father. And closer home, if you all have been to Belur, which is a famous Hoysala temple of the 13th century, this has sort of been patronized by the Queen Santala Devi, who herself was also a dancer. And if you see in this depiction, she's seen holding a mirror. And this is, of course, a typical depiction which also animates the dance traditions, and you can see that inspiration there. And why I come to that is because one of my very important studies was on the documentation of this rare mirror-making craft from Aranmula. And what is quite interesting about this mirror-making craft, of course, the reflectivity of the mirrors are as good as modern glass mirrors. But these are metal mirrors. And what I'd like to point to is that these were made by very specifically optimizing a particular intermetallic compound phase in the Copperton system, Copperton alloy system, where they've really been aiming to isolate this intermetallic compound of Cu31SN8 of a composition of 32.6% tin, which is the delta phase of bronze. And that's why I call these delta bronze mirrors as well. And that was confirmed from the microstructural analysis. As you can see that this consists predominantly of this silvery white delta phase and very minor amounts of the alpha plus delta eutectoid. And this delta phase is also very hard, which is why it can be polished very well and takes a very brilliant, it has very good specular reflectance and so on. Because as you know, of course, silver would be an ideal material for a mirror, but because it has very good reflectance again, but it's a very soft metal and it gets dented very easily. So in this case, this delta bronze is very hard and it does not get dented. And it also gives a point image, unlike, let's say, the current mirrors, which are mercury with a thin layer of glass on top, where there is a loss due to refraction and so on. And what is quite interesting is that using very simple low-cost techniques, they managed to isolate this alloy and cast it to a very perfect blank, because the idea is that it's a very brittle alloy, but the idea is that if you cast a very thin blank, then at least the more of homogeneity is ensured, and so it's less brittle. So they devised this very ingenious two-piece crucible cum mold. So this is the two pieces of the mold here, and this is the thin gap into which the metal would have flown and then solidified into the blank. And I call it a crucible cum mold because here is where the metal to be cast would have been placed, and then the whole thing is sealed to get a closed crucible here. And again, using a closed crucible was also advantageous because it meant that there was not much of interaction with the air, which would have actually oxidized the metal and given a worse casting. So a lot of minute nuances seem to have been looked at in the whole process. And here you can see this very brittle alloy is first broken up and then packed into the top of the cup of the crucible mold, and then it is covered with numerous layers of clay and heated face down in the hearth, and then taken out of the hearth, and then the metal flows in. And this is a view of the beautiful Aranmula temple. And in those days, this was still practiced only by a handful of families, but this is Janardhan Achari with his wife, who was also very active in the, in terms of the activities, the metallurgical activities. And here we tried to use a thermal camera to just see what was actually happening in the furnace. And as you can see very clearly, there's a very big temperature differential between the molten metal up here, which is cooling down from at least about 700 or so degrees down to the bottom. The base of the mold is much cooler, and that differential also, I think, helps. It's almost like a chill casting, or something closer to a chill casting, so that ensures some kind of homogeneity in the blank, which is really what we need. And we need to have as few defects as possible, because then it needs to be polished in a very to get a very flawless mirror blank. And these are also the molds which had a very fine slip put onto them, so that you get very fine mold, surface of the mold for the casting. And then the blank is set upon a wooden polishing mount, and then it is lapped back and forth like we would in a metallurgical polishing as well, to get rid of all the scratches and so on. And this was the largest metal mirror which had been made in the workshop of Janardhan Achari, who passed away many years ago. And his daughter Sudhamal has been the one who has been carrying forth the tradition. So that's also quite heartening, that in many of the places where the elderly master craftsmen have passed away, quite often it's the women, the wives and the daughters and so on, who've been getting more involved in taking forward the craft, though perhaps more traditionally their roles would have been, a little more secondary and so on. And an interesting dimension to me was that it's almost as if this kind of wooden polishing board itself, with the mirror mounted on it, could have been used as a mirror in antiquity. And I think in a way that sort of corresponds to what you see here, perhaps in this very beautiful image of the Hoysala Madanika. And earlier this year, I was also able to get the Rijksmuseum to commission a making of the Aranmula mirror, and so that Sudhamal and her family would have a good commission for the Asian bronze exhibition in the Rijksmuseum. And very sadly, she had a bad accident in the foundry, and she's had a leg amputated and so on. So these are the hazards that are still faced in the traditional setting and so on. So all the more reason why we need to try and encourage and foster these crafts. Well, of course, since I'm talking to a group of astronomers here, we do know that the speculum metal was already being used in the 18th century and so on to make astronomical telescopes. And I was able to visit this wonderful facility of the German-British astronomer William Herschel, who discovered the planet Uranus in 1781. And this is his hand polishing unit in this Herschel Museum. And Of course, the speculum metal that was used here, although it is again a higher tin bronze and it's said to have had 2 parts of copper and 1 part tin, but they also had some other elements added like arsenic and silver, lead and zinc. Whereas the point about the Aranmula mirror is that it is very specifically a binary heightened bronze. And even the Chinese mirrors, China of course is very famous for the mirrors which were made from the Han Dynasty onwards. And they also were higher tin bronzes, but quite often they had lead added to them because when you have so much of tin as the Aranmula mirrors do, they become very brittle, whereas the addition of lead would have had the lead flowing into the dendritic spaces and hence reducing the brittleness. So the Chinese mirrors, they do have more lead in them, and I feel that would have actually reduced the reflectivity and perhaps made the mirrors a bit more opaque. So in that sense, the Aranmula mirror is really the classic front-facing mirror. And if any of you were to probably send it up into space, it would not tarnish, probably provide a very good mirror for astronomical use in terms of, taking the past into the future, perhaps. And this is just to point out that I was able to analyze an old bronze mirror which had the Gandaberundam motif of the Travancore royalty. And the astonishing thing is that it's almost entirely pure delta phase. There's almost no granular alpha plus delta eutectoid, so that they were able to achieve this, almost perfect delta phase composition just using traditional means is quite astounding. And looking at the archaeological record, there is a report by Greeks from the Nilgiri cairns of about the early 19th century, where he reports a mirror with 30% tin, which is a bit similar to this. But again, we have to go back and actually identify the object and analyze it because these are just the archaeological reports. And we could say that maybe this kind of technique could have been used to make mirrors in antiquity in terms of those thin castings, because we do find these kind of flat circular mirrors, even from the Harappan context, from Quetta in Pakistan. But the composition, those would have very likely been low tin. I don't think they were making them heighten in that early period. But of course, a bulk of my research in the earlier days was on the celebrated medieval statuary bronzes, as kindly mentioned. And this is a beautiful example of the Chola bronze from the Government Museum, Chennai, depicting the Hindu god Shiva as the Lord of Dance, which Ananda Kumaraswamy, who was himself a Renaissance personality, and he described it as poetry, but nonetheless science. And that is one more kinship I have with Dr. Annapurni Subramaniam, who's not just a very famous scientist, she's also a brilliant Carnatic violinist, following in the parampara of her father and so on. So that idea of drawing together science and culture is something that is also, in a way, being one of my own, preoccupations. And this had been analyzed again by spectrochemical methods and found to have 8% tin and 8% lead. And this is a view of the Nataraja, which was installed in the CERN Cosmic Lab by the government of India, and it had all these quotes of Kapra and Kumaraswamy, of course, pointing more to the poetic imagination of contemporary scientists who looked back at this image and found some kind of, some kind of poetic resonance in a way. Not that these are to be, taken beyond their context and so on in that sense. But the quantum physicist Fritjof Capra in his book had also talked about how this image suggested to him the dance of subatomic particles, the dance of Shiva and so on. And even Carl Sagan, of course, he worded it in a more restrained way to say that the imagery holds out what he, I think, very beautifully put as a premonition of modern astronomical ideas. Maybe in the earlier pre-modern context, it is one of those images that seems to convey a sense notion of the cosmic forces of creation and destruction. And some of the devotional poetry also does, at least from about the 13th century, seem to convey that, as pointed out by in Kumaraswamy's translation of the Unmai Vilakam, where Ananda Kumaraswamy describes how the image depicted the balance of Srishti or creation as depicted by the drum, and Samhara or destruction as depicted by the flames. So both of those are balanced in a way. Of course,
I was also involved with the actual study of the metallurgical techniques of manufacture and so on. And these are made by the age-old process of lost wax casting of metal icons. And here the wax model is first made of the image to be cast and then covered with numerous layers of clay. And it is, of course, described as the womb in a way because it's almost like a birthing process. The word in Tamil is karu. And then the wax is melted out and then the molten metal is poured in. And this was a microstructure of one of the Chola pieces that I looked at. And since I talked about the Aranmula mirror, you can see here that the colors are completely different because this is a low tin bronze. It's very coppery. And you can also see that the intergranular spaces here is taken up by the lead, which is added to make the metal more castable because tin bronze without lead is not very castable. And of course, this is a technique that we see goes right back to more archaic times. This is a celebrated Mohenjo-daro dancing girl of about 2500 BC. And, she does seem to have her hand on her hip in an attitude which you still see, for instance, in Bharatanatyam. That's a very common posture. So it does bring to mind some continuities. And her hair is also done in a sort of bun or kokot, which you still see in the tribal communities in the Nilgiris, the Kota women, and so on. And of course, the Manasolasa is also makes a mention of the lost wax process as Madhu Chehiste Vidhana. And there is also a beautiful verse of the Tamil poetess Andal, which also describes the lost wax casting process in a metaphoric sense, where she says, Ullai ulla meligu urukki vengalamootra vali seyvadu pol. So she's describing the melting of the wax and if it flowing out of the mold and making way for the bronze to flow in. And of course, she compares that with her devotional ardor for the Lord Vishnu and, wishing for the clouds which she compares to the molds to rain down on Venkatam or her beloved Lord Vishnu and so on, which is part of the Bhakti milieu. So coming to the analysis, one of the techniques that I had used to analyze the bronzes, because one of the major problems is that it's not easy to date and classify bronzes because there's no absolute dating technique like carbon dating. So we have to look at the metallurgical profile to provide some clues as to differences in metallurgical profile over different time periods, which could help us to then build up a calibration, and then we could try and figure out some dates for some bronzes of uncertain attributions and so on. Of course, it's a complex and ongoing thing, I would say, but the reason why lead isotope ratio analysis was very useful is that different ore deposits can have distinct lead isotope ratios, which are measurably distinct because it depends on the geochemistry of the uranium thorium geochemistry and the history and the geological age of the formation of the ore deposit and so on. And so typically an object which has been made from a particular source will likely have the same lead isotope ratios of that ore source. But of course, there are problems and there are mixed lead and all that. But then it does help us to some extent to try and provenance artifacts. And for example, it's not always very easy because we do need to have the lead isotope ratios of various sort of deposits for it to be successful. And I don't think we have the full picture for the Indian subcontinent. But for example, for this image, which is a Buddha from Kanchipuram, I had done the lead isotope ratio analysis, and that was found to closely match the Ambaji mine in Gujarat. And which is of about the 13th century period. And this is the Solanki period that we're talking about when this famous Rani Ki Vav was also made. So it's quite likely, it seems likely that the brass in this case was coming from this ore deposit. And this had about 21% zinc. And another interesting aspect was that the lead isotope ratios of this Buddha from Kanchipuram did not match Zawar, although this has, as I said, about 21% zinc. I would have expected it to match Zawar because Zawar is the one site where we know for sure that metallic zinc was extracted in early antiquity. At least by about the 11th century, we have these retorts which were excavated by teams from the British Museum and so on, Paul Craddock and others, and found to be of at least about 11th century. So it would have been
Not so surprising if it had matched Zawar, but it is actually matching Ambaji. So it seems that that also might have been a source of zinc, and we probably have to look at the evidence there for extraction and such like. And what I'd also done was, as I mentioned, I'd undertaken inductively coupled optical emission spectroscopy for about 150 of these images. This was when I was also doing my doctoral work at the Institute of Archaeology in London. And of course, the major elements tend to vary randomly. But what was quite interesting is that there were certain clusterings which could be identified in the trace elements, particularly elements like nickel, cobalt, antimony, arsenic, and bismuth, which are more chalcophilic, and so they tend to, they tend to segregate out with the since they're part of the copper ores, they tend to segregate out into the copper metal. So in that sense, one could get some kind of clusterings by, grouping these together, which actually had some resonance in terms of the dynastic chronology. For instance, the lead-acid ratios and trace elements of the Chola period were different. The Chola period was broadly from about, let's say, the mid-9th to about the mid-12th century, the imperial Chola period. And so that was quite different from the profiles that I was getting for the Vijayanagara period, which was somewhere from about 1336 to 1536 CE. So this suggested that this was brought about because of the use of different ore sources for the different periods. So anyway, it is a bit complex and one is doing further work. But since I had mentioned the zinc smelting, I should also say that there is actually a lot of textual resonance also in terms of understanding the zinc smelting processes, which is quite interesting because some of the iatrochemical texts did actually document some of the processes, and we clearly see that in the case of the zinc smelting, because it is described as Tiryak Patana in the Sanskrit Rasaratna Samuchaya of about the 12th century, and Tiryak Patana literally means the downward distillation. Now, the point about the smelting of zinc and why that emerged quite late in terms of archaeological discoveries and so on is the fact that it is actually quite difficult to extract in a metallic state, because at the temperature at which you would smelt the zinc, it turns into vapor very easily. So you don't very easily get it in the metallic state. So what they actually had done in Zawar, and which was discovered due to the finds of all these retorts, and in fact, if you go there, and I've also seen them along the hillside, I mean, in earlier days, there were these huge slag heaps with the retorts and so on, but then they've been taken away over time by villagers for housing and so on. So there aren't so many left there. But what they actually were doing was that they were using these very specific retorts, which had these condensers, so that it was heat. The top of the furnace was packed with all these retorts, which had the charge, the zinc ore charge. And so this was then, let's say, heated. This is a perforated furnace, which was heated to about 1100 degrees or so. And the point was that the zinc vapor could then very rapidly cool, going down to the bottom of the furnace through the perforations, where the condenser stick was pushed through that. So it was a very drastic cooling of about 500 degrees centigrade, so that it wouldn't just vaporize, but it would actually solidify and condense into these globules, which would form at the bottom of the furnace. And here we're also doing some XRF analysis on some of the retorts that I had collected on a trip to the Aravallis. And what was quite interesting was that I had actually studied this coin ingot, which has a Deccan Brahmi inscription of about the 4th century or so. And this is actually associated more with the Deccan region, the Andhra region. And this again had lead-acid ratios which did not match Zawar. So clearly this metallic zinc is not coming from Zawar. I haven't actually identified the source, but it's quite interesting that it has a southern Indian connection. And we also know that Nagarjuna, who came from the Andhra region, he also mentions the use of calamine or zinc ore as an eye salve. So that I also found a bit interesting there, the significance of that. But if you see the coin ingot, you can actually see that it's like a solidified droplet or whatever. The one part is just flat and the top is more globular. So it looks like it's something that they just collected from the bottom of that furnace. And of course, as you know, that in the Indian tradition, so many of these cultural and philosophical traditions were all very interconnected. So I was also struck by the use of this term rasa. Of course, rasa could also refer to mercury, which also sublimated. But rasa also keeps coming up in the context of the descriptions of zinc, because rasa is something which those of us familiar with the Natya Shastric traditions, the Bharatanatyam or the classical dance traditions, rasa is really a kind of distilled essence, a distilled aesthetic experience. And so this idea of a distilled aesthetic experience is also something, again, you see in the idea of the downward distillation here to extract the metal. So I found that coincidence also quite intriguing in a way. Now coming back to the lead isotope ratios, so if you all had been looking at that plot more closely, there were some outliers, but there is one lump which represented a lot of the South Indian bronzes which are analyzed. But if you sort of went closer into them, it sort of resolved into minor clusters. And what was quite important is that they do seem to have some chronological consistency within them. For instance, this cluster represents mainly the Chola bronzes, and that up there, the Vijayanagara bronzes and so on. So I don't have too much time to go into the details, but I wanted to point to some important findings to point out how the actual chemical analysis or the metallurgical analysis helped us to make some identifications which were actually missed in the art historical process. Because when we're just classifying by visually looking at some artifacts, these kinds of markers are missed. And so the scientific criteria gives an additional set of criteria by which one could classify artifacts. And one of the, for instance, this is a image of Nataraja. And we had normally believed, even if you look at all the art historical literature, it's generally thought that the classic pose of Shiva dancing in what we describe as a Bhujanga Trasita Karna with the leg extended like this particular depiction of Shiva, which is identified. It's also a depiction which is only found in Tamil Nadu for some reason, but this is thought to have emerged in the Chola period. But I was able to identify this image which did not fit the Chola fingerprints, but rather fitted the Pallava fingerprints. And the Pallavas were a dynasty who were slightly predated the Cholas from about 600 to 875 CE, of course, famously associated with the monuments of Mahabalipuram and so on. And this was interesting because this image also, which is now in the British Museum, had been labeled as a Chola image. But after this analysis, I could see that it actually does fit the Pallava stylistic features quite well, which had just not been thought likely or possible because it had always been imagined that it was during the Cholas that the entire bronze tradition actually emerges. And there is a very beautiful frieze here from Siyamangalam of the 7th century, which shows Shiva dancing in Bhujanga Trasita Karna, which is typically actually described as the serpent fright, sort of retracting or recoiling from a serpent. And here you actually see the depiction of the serpent here. And you can see in many of the sashes and so on, this is a very Pallava depiction, the front-facing dwarf and all that. And these are some of the other images from other periods which I had analyzed. This was also a famous set, the Somaskanda, which is fingerprinted to the Pallava period here. And this is a Chola, typically Chola bronze of the Rajaraja Chola era, which art historians also agree that it is a Chola piece, and that fitted the fingerprints for the Chola period. And this Kaliya Krishna fitted the fingerprints for the Vijayanagara period. And I must say that I didn't find any Natarajas fitting the Vijayanagara period. And that's not surprising in a way because by the Vijayanagara period, it was much more of a Vaishnava dynasty and it was not so much of prominence given to the Shaivite worship. And this is quite typical of the kind of style. And you do see this kind of Kaliya Krishna depiction also in the sculpture at Hampi and so on. And this is, of course, an early depiction of Parvati or Somaskanda, also from the Chola period. But one aspect I wanted to touch upon, because we're here in an astronomical institute, was also collaboration that I had done with the late Dr. Nirupama Raghavan, who was also heading the Nehru Center in Delhi and so on. And it's a very, unfortunately, she passed away before some of the work could come to fruition. And I couldn't actually find a photograph of hers to put in. But speaking of the Gender Association, I'm very glad to be able to pay a tribute here to this lecture. So at the coastal temple of Chidambaram, which is dedicated to the worship of Shiva as Nataraja, there is this dual worship where Shiva is worshipped also as the Akasa Lingam, or the formless space. And in the old days, that used to be also described as the Chidambara Rahasya, where you had the anthropomorphic worship of Shiva as well as this curtained empty space which represented Akasha. And that is also the only temple where Shiva is actually worshipped in the anthropomorphic form in the main sanctum, because in all other Shaivite temples, according to Shaiva Siddhanta practice, it is the aniconic lingam which is worshipped inside the main sanctum. But there is also an interesting tradition at Chidambaram that in the month of December, there is this festival of Margari Thiruvadurai, which is that it is the worship of Arudra, or Arudra is associated with BT geese, and BT geese is associated with Shiva or Rudra. And also the constellation Orion with BT geese is seen very visibly right in the zenith, and I've seen that in Chidambaram in December. And of course, there's also a processional festival that goes along with it. And so she had postulated this idea that there's a connection with the iconography of Shiva Nataraja. So I gave her the specimen of the bronze that I had analyzed and found to be of a Chola, of the Pallava period. And so she plotted a star chart of the Pallava period, or rather of that kind of era, 800 CE or so, onto this image of Shiva Nataraja. And this is, of course, an improved version of that. So it is an interesting idea that the iconographic formulation of the Shiva Nataraja may have been inspired by the star positions of the constellation Orion, with the belt of Orion aligning along the waist. And but of course, one thing which I noticed was that I think that the leg extended out like that could also have some significance in the way it is sort of pointing out towards the star Sirius, which is also known as Mrigavada it is also goes back again to Vedic literature and so on, the dog star and so on. And so this was just, of course, in those days, what did they have better to do than to just look at the constellation and so on? So it's not totally, out of, it's not totally far-fetched and so on, though we still have to find the textual evidence. But we do know that there is also a tradition amongst the Chidambaram Dikshitas where they do mention this Arudra Tandava Darshanam as something which had this kind of connection, because there's a sketch here that one of the Dikshita, Raja Dikshita, who's no more, showed me from Chidambaram, which depicts the star positions of Orion in relation to the Nataraja image and so on. And in Tamil it says here also Arudra Darshanam and such like. And another aspect is that, yes, as I said, the archaeometallurgical fingerprinting also matched. And I also looked at some of the sculpture which Nirupama had also done, but this is another sculpture that I looked at from the Kailasanatha temple, which has very large sculptures. And again, this idea of the positions aligning along the body of Shiva Nataraja. And there is also, in fact, another sculpture which I haven't shown here, where there is a depiction of, it looks like there's actually a dog depicted here, which where Sirius is associated with the dog and such like. So there's some more aspects, and why not? Because, as I said, but this does tie in with some of the more mystical aspects of the devotional poetry. For instance, Manika Vachaka singing, when will I get to gaze upon him who is earth, wind, fire, and water, Adiyam Antamam Illadavar, and so on, the one who is without beginning or end. And this also inspired to some extent the performance that I had done at IAA, which I'm very grateful to Professor Siraj Hassan, where we had done this at Crest in 2009 for the Year of Astronomy. There was a dancer in Toulouse who was dancing in the contemporary form, and I was doing Bharatanatyam, and so we were dancing in and out of each other's virtual bodies, which was to also convey all of these ideas of cosmic creation and destruction and so on. But let me come back a bit to how much time do I have? 10 minutes? Okay, very quickly, some other aspects of the archaeometallurgical work. So I talked about the use of the delta bronze alloy, but there's another very interesting aspect, which is that although the Chola bronzes are all low-leaded tin bronze, it's not as if they were not aware of the use of bronzes of a higher tin content in earlier antiquity. And in fact, this is a microstructure of a bronze vessel from Adichanallur, which goes back to, in fact, the dates now for Adichanallur are really going back, I was going to come to that, some very early Iron Age dates. But this, which has been loosely dated to the early to mid first millennium BC, this is made of wrought and quenched heightened bronze, where they were, specifically going for this composition of the beta phase of bronze, which forms at about 23% tin. And the idea being that it becomes very plastic and can be, highly forged. This beta bronze alloy can be highly forged. And then when it is quenched, it retains this martensitic beta phase, which gives all sorts of good properties. And this is what happens when you don't quench it. It is that alpha plus delta eutectoid, which embrittles the bronze, which forms. But the quenching actually improves the bronze. And there's this find from Adichanallur. And now we have very early dates, in fact, going back to about 1300 BC for Adichanallur and those kinds of finds that I'll touch upon. And this was just to show this foundry where they were actually making these heightened bronzes in Kerala. So I could say that it was actually a long-standing continuing tradition, and then the heightened bronze alloy, when it is polished, you get this very spectacular golden finish. And why it is interesting in terms of an astronomical or at least history of science context is I found this particular piece, which somebody had mentioned to me that it's a water clock because it has a hole down here. And this Gatika Yantra is said to have been used for time measurement because it alternately sinks and floats and so on. And Bhaskara's Leelavati also mentions the Gatika water clock. And again, this looks to be of a heightened bronze. And we also have some similar objects coming up, for instance, the Nilgiri cairns that I had mentioned, Iron Age, early historic. And again, I was also able to document also this has died out though in Palakkad, not only the manufacturing, but also making these kind of concentric rings and so on that you see here on using traditional hand lathe. And going all the way back to the Iron Age urn burial sites, this is Shivagalai, which is very close to Adichanallur. And so this is one of the bowls found there. And from portable XRF, it does seem to be a similar composition of 24% tin bronze. The one has to actually do the metallurgical analysis for which they have to give us the samples. But Shivagalai, it's also very amazing because I'll come to the story of iron and steel. If you just give me 5 minutes. One of the important studies that I'd also made was in the identification of the use of high carbon steel known as woods. Now, typically wrought iron has very low carbon and cast iron has quite high carbon, but what we call a high carbon steel has a composition of about 1.5 or so % carbon. And what is quite interesting is that this steel, it also had certain properties which were then identified by Sherby in the 80s, the ultra high carbon steels, that they were actually super plastic. But it also explains how they were actually able to forge these ingots of high carbon steel to make these blades which had this watery pattern, which was much sought after in the Crusades and so on, the Damascus blades and such like. And I was able to identify a production site where this is a sort of microstructure which shows you this solidified globule of ultra high carbon steel. So it has a typical structure of, this is the prior austenite grains, honeycomb prior austenite grains. And then when it solidifies, it transforms into pearlite, and then the cementite network is there. So that's exactly what has been forged here to get this alternate light and dark structure, these wavy bands after it's etched. And it also spurred a lot of studies in terms of history of metallurgy, where people like Michael Faraday and many others have, many alloys were actually discovered in just trying to understand how this was made and so on. But, and it's interesting that Zosimus, the Greek, had already mentioned that Indians fused iron in crucibles to make weapons. So this was a crucible carburization process where
these high, carbonaceous crucibles, highly refractory and carbonaceous crucibles were packed with these wrought iron ingots and then, heated to very high temperatures so that in highly reducing conditions, so that the carbon directly got into this, steel. So it was more like a kind of molten carburization, which happened at very high temperatures, as suggested by these, the structure of these frills and so on. And the term Egu also appears in Sangam Tamil texts. In fact, the poetess, talking about gender, the poetess Avayar often refers to the term Egu, and she talks about the poems dedicated to the chief Anchi. And these were again some of the spears which were found from Adichanur. And some more studies that I've made, this is from Kodumanal, the site that I had mentioned, 5th century BC, which this is the electron probe microanalysis dot map, again identifying these remnants of metallic iron, suggesting it was used for crucible carburization. And now in the early century CE, we also have the Roman accounts which mentioned iron from the Ceres. And this Ceres might refer to the Chera kingdom of this domain, because we know that in the early historic period, there was a lot of Roman trade also with southern India, and the site of Muziris in Pattinam. Pattinam has also been conflated with Muziris, which has been excavated by the Kerala Council of Historic Research and others, Palma by P.J. Cherin and others. And this was a nail fragment which I had analyzed from Pattinam, and this is classic ultra high carbon steel composition. So this could well have been one of the items of export to the Roman world and so on, as suggested by some of these accounts. And speaking of women, of course, one of my collaborators also in the study of crucible steel from the Telangana region was Dr. Jill Jolliffe, when we had this NIAS Exeter grant. And these are some of the crucibles from the Telangana region. And what you're actually seeing here are, again, the crucible part of it was made more refractory by adding all these rice hulls and so on. So that also, when they were charred, there was a lot of siliceous material as well as carbonaceous material, which contributed to the refractory properties and the carbon going in. But we also found some remnants here of cast iron as well, cast iron frills. So it suggests here that there was another process. The earlier process is closer to what we call the Mysore process, where it was the carburization of wrought iron, which we see also in Tamil Nadu and so on. But here it seems to have been that there was some cast iron produced, and then that was, fired along with lower carbon wrought iron to get a steel of an intermediate composition. So this also is quite intriguing, that there were some remnants of cast iron which we don't normally associate with, let's say, the Indian subcontinent and so on. And the crucibles also had a lot of evidence of, traces of zirconium-rich minerals, which is also quite interesting because some of the sands in the Andhra region do have zirconium-rich minerals, and whether those were sort of being deliberately added to the matrix of the crucibles to make them more refractory, because zirconium is a good refractory material. Since I'm in Karnataka, I can't not mention the famous ferrous metal case rockets of 18th century Mysore. And these are some of the Tipu era rockets which were uncovered from Nagara. And so we had worked with Malika Ran, Sejeshwar Naik and others to do some, again, spark source mass spectroscopy, and found that these made by, very skillfully, seems to be some kind of rolling technique to make these metal case rockets of mild steel, which were also then used in the Battle of Poliur, and they were packed with propellant and so on. And Francis Buchanan also mentions that these steel forges were used to make strings for musical instruments. And coming back to my theme of women, this is a beautiful depiction here in the Darya Daulat Bagh palace of Srirangapatna, where you see the women actually playing various instruments, something which looks like the tambura. And here you also see the violin, which was coming in at that time due to the influence from Europe and so on. And I think I've just got 2 slides. So I just wanted to mention also the Kalaripayattu tradition, where there is also a tradition that Uniachi was a well-known woman exponent of Kalaripayattu. And this was the daughter of a famous Kalari master in Kozhikode.
who was also a very great culinary expert. And there's a very special kind of blade that they use, which is the urumi, which sort of can be completely coiled and then it sort of springs out. It's quite a deadly instrument. This is one of those old master craftsmen. And the composition of this blade is actually spring steel, which is quite interesting because there's a spring steel is also what was used in the clock manufacture in Europe since 15th century, and whether this also had been something which had been used in earlier times. And this is my last slide here, which I had talked about Adichanilur. So we've had some very, well, it's been in the press a lot, some very extraordinary findings, which of course there is still some debate on how seriously some of the dates can be taken. But in recent times, the Tamil Nadu State Department of Archaeology has very, in a very kind of calibrated move, they've been sending all their the charcoal for carbon dating to the best laboratory, the Beta Analytics laboratory in Florida and so on. And astonishingly, Shivagalai, the urn burial sites of Shivagalai and Adichanur have some very early dates, as I said, coming from these top laboratories, so they just can't be discounted. Going back to even prior to 2500 BC for the use of iron. And of course, so there is a lot of discussion there, and it's not the only, one-off kind of dates. There have been other sites in Tamil Nadu, like Mailadumparai, which have also had very early dates of about 2000 BC. So this whole question has, come about as to, how and whether this is possible. So one possibility which I had raised, if the archaeology is all sound and if these dates are sound, is that it's possible that, because here what you're seeing in Tamil Nadu, it's almost like leaping straight from the Neolithic into the Iron Age, which is not really possible without going through a copper smelting phase. But one could entertain the possibility that some of the Harappan copper smelters could have migrated along the sea route to coastal Tamil Nadu, and then finding that there weren't that much, that many copper ores because the southern tip is not as rich in copper ores, let's say, as northwestern India. And then they might well have adventitiously discovered iron smelting. And one very uncanny aspect, though, is that, a reason to not dismiss this as another nutcase theory is that, some of the finds in Adichanilur, you get this figurine which has been described as a mother goddess, which has very uncanny resemblances to the Harappan terracottas of mother goddesses and some other kinds of animal figurines. I don't have too much time to go into that. So but anyway, these findings have really, set in motion a lot of churn and rethinking about the antiquity of metallurgy in Southern India. Certainly, when I started, we only thought about the Chola bronzes and we thought that that was a sudden efflorescence and there was nothing much else going on in Tamil Nadu or in Southern India. But as you can see, there was definitely a very early tradition of heightened bronzes used, which at least, the dates for those are from Shivagalai with very reliable dates and paddy and so on. That's about 1200 BC or so. And now we have some of these early dates for iron. So I think there is a lot of interesting dimensions there to pour over. And anyway, since this is one place where I can show off some of these things, I was featured in this exhibition on STEM earlier this year, and then that was the American Academy induction. And there was one with IIC Professor Balram, the Women's Science Award, and some of my women colleagues. There are several other very eminent women also, even in India, working in this field, such as Professor Vibhatapati, who's was more an archaeologist, but also been writing on the iron legacy. Dr. Vandana Singh, who's a conservator, wetlands conservator, and Sarishta Chatterjee is also. It's good to know that there is a lot of momentum now, at least starting going compared to the time when I got into this field. So thank you so much to all of you here at IAFA.
Thank you, Mr. Srinivasan, for a very interesting talk. Do we have time for questions? Yes,
I was struck by your discussion on the composition of the Chula bronzes. And I was wondering, when you analyze these artifacts for the composition, how do you extract out the samples?
Yeah, well,
These are priceless artifacts from sample spaces.
Yeah, so there are these trained techniques in conservation science, which is you'd use a micro drilling technique. So you can use these tungsten carbide drill bits, which go from less than a millimeter, 0.8 millimeter or something. So these are luckily solid cast bronzes. So it goes in about, let's say, a half centimeter or something, or even more. And so you can collect about, say, 50 milligrams if you're lucky. That would be good. But sometimes if you have very sensitive instrumentation, you can manage with 10 milligrams. But, to be safe, collecting at least about 50 milligrams. But again, it depends. Some, labs want much more. So it depends really. But I was lucky at the time because the lab that I was working with needed very little sample. So that was.
Mentioned that Harappan, the Harappan artist, I would say, migrated to Tamil Nadu while still.
But it's just a hypothesis to explain this anomaly of these very early dates.
Why would you choose to one direct overland? I mean, Harappa is not very close to us.
Well, it is actually, if you look at it, especially early, the Baluchistan and so on, that is quite coastal. And from there, they went all the way to Oman and so on. So and then of course, from those parts, I mean, the pre-Harappan Mehergarh and all that is in Baluchistan, which is by the Makran coast anyway. And then they then came to Lothal and so on. So they were, very strongly seafaring. So in that sense, it's not implausible that if they could have gone all the way to that, to the Arab, to Oman and so on, it's just a theory. I mean, it's suppose, and the reason why I say that that's one plausible way of looking at it is because actually when you think about it, I mean, okay, there's the other way of looking at it is that there's a late diffusion, into the south, which comes via the land route. Because if you go by the land route, then all of this should have been coming to Tamil Nadu last. But now you're finding, so many kind of unusual things about Tamil Nadu, which, for instance, you find a lot of these metal figurines and so on, very tiny, no doubt. I didn't have time to go into all of it, which you're not finding so much in the, let's say, intervening places. And these very early dates, let's say, even for the heightened bronzes and so on, which are coming from this area. And also now, I don't want to go into it, but also the early finds of these graffiti marks, which some of them seem to correspond to the Indus signs and so on. So it's not totally implausible that there was some movement in that sense. Though, of course, one has to do much more of the archaeology to really figure it out. And even the other, I don't have time to go into it, but the Tamil region is where you're actually finding things like this evidence for, the diamond drilling and the quartz beads and many things which actually go back to the Harappan ethos. And like in Karnataka, you find even less of the use of these bronzes and stuff. Well, one explanation could be that actually Tamil Nadu has been very proactive with archaeology and scientific archaeology. I don't know what the others have been doing. But in the absence of that, we can say, I mean, I don't know, maybe it's a continuum, but even so, see, I mean, there have been quite a few. If you also look at the quantity of iron found in Tamil Nadu, it's very significant, there's a lot of it. Of course, you could say there's a lot of iron available, but to think then it's not inconsistent with the fact that you're getting these early iron dates, let's say, in that sense. The fact that you're getting a lot of iron in Tamil Nadu, I think much more than you are in other places. In that sense.
That's good. Lothal as a dockyard.
Sorry?
Lothal as a dockyard.
Could have been, yes, it has been theorized as, yeah.
Seafaring.
The seafaring evidence is definitely there from the Harappan region. That they were going to Oman is without doubt, because you have these carnelian beads also which find their way. Of course, you find those carnelian beads all the way in Mesopotamia. And they were clearly being made in the Harappan region and so on. So,
But what the continuity is, for example, you have Harappan at 2000, 3000. And here is another. There's enormous gap.
there is actually, it is a long hiatus also. It's not that it's very easy to figure out because there is huge gaps as well.
And the
But
techniques have been retained.
that's true. But see, so those are the puzzling things, which is the fact there is a hiatus after the Harappan period, there's no doubt about it. But still, some of these things seem to linger on, as sort of very archaic practices. I mean, I'm not saying that they were making heightened bronzes in the Harappan period. I don't say that, but they were forging bronze, and it was also binary bronze, unleaded bronze that they were forging. So to that extent, that forging of binary bronze, you do see there is some, it could be. And in fact, Mackay reports 2 pieces which had 22% tin or something from, from Mohenjo-daro, but we don't know that that was, quenched heightened bronze, but just the fact that they may have been experimenting with different compositions of bronze and things like that. So all I can say is that though we don't see too many links in a way, and there's not a lot of intervening evidence, some of the Tamil Nadu Iron Age, if you have to look for some parallels or some things that you can, some precedents, then it does seem to hark back to Harappa more than, I don't know where else you could compare it with, but in the absence of anything else to compare. So it's not inconsistent with that. Put it like that.
That's it.
I have a question on this Nagraj Shiva dance which you have. So it's obviously religion and art is obviously related, but I'm just curious the scientific interpretation of science, especially in physics, the Nagraj dance depicts as if the creations and the destruction of the universe through fire. I mean, is that kind of very recent interpretation, or is there some link to scientific thought?
I mean, I think it's, it's mainly an intuition or whatever. I don't think there's any anything to prove that there was it was anything beyond poetic intuition. But as poetic intuition goes, it's quite it's special in the sense that it's not there in other cultural traditions in that way. If you look at the creation myths in other traditions, there isn't that like, some of, at least there is some sense, I think, of reconciling, or rather dealing with form and formlessness as, differing versions of each other and so on. Some kind of engaging maybe with abstractions. I don't say that, but I don't know, like, I mean, there are some uncanny intuitions, that's about all I can say. And I suppose it's worth pointing to it in a history of science context. I wouldn't know if it actually holds ground in terms of scrutiny, in terms of modern physics or whatever. I wouldn't go that far, no. But certainly for its time, I think it was quite an interesting philosophical idea. And certainly if you look at some of, I mean, there is some kind of mystic, vision behind it. One could say that.
Yeah, so by analyzing this script, Ascopacola suggested that it could be Dravidian. And you are now finding a lot of connection between script and Harappan being Dravidian.
Yeah. So of course, I haven't gone into the script studies and things like that. Well, all I can say is that I certainly won't rule that out, because there is from the material evidence, which is what I'm mainly looking at. One thing that, and I didn't have time to go into it, one thing that you see with the Iron Age in Tamil Nadu is that there are these little figurines, metal figurines, which if you have to find a parallel, you do find it in those miniature, terracotta figurines and other kinds of metal figurines, which you find from the Harappan assemblage or whatever. And I showed the Adichinallur, I mean, that mother goddess is one example. So again, that suggests a connection. So, I mean, I don't know about the script aspect, but of course, I think there's been enough of publications to show that if you're talking here about, Sanskrit, that it seems to be much more of an Indo-European connection, and even recently there were some studies about how it is associated with the Yamnaya of the steppes and so on. So that is the broader thinking or connection or whatever, or from the genetic tracing and so on. So in that sense, yeah, if it was not that, then it could have well been. And you do have the fact that there is these pockets like in Balochistan where they do speak Brahui, which is another kind of branch of, the Dravidian or whatever. And so from the linguistic, and in fact, now that you asked me, since you've pinpointed this to ask me, I actually found one very interesting aspect that the term that they use for the heightened bronzes in Kerala, they call it Olavattu or Talavattu. And that term Vettu, and then if you look at the Chola inscription also, I found that Vettil appears in the Chola inscription as a description for a vessel or a kind of bowl, which is what that heightened bronze bowl is. So it just turned out that quite by chance, I was on some there was some website, Indo-Pakistani website or something, and there was a illustration of this vessel which looked like a heightened bronze vessel. So and some Sindhi commentator said that this is watau. Yeah. So I said watau, and it's very strange because that's totally different from the Sanskrit inspired word that you find in, say, where in Eastern India, where it is Kansa, Kansa comes from Kastira. Kastira is cassiterite, basically. It's the same root in Greek and in Sanskrit, Kastira, cassiterite. And then out of that comes Kansa, which refers to height and bronze and so on. And that's what they use a lot in Eastern India, Kansa Vanix. But this is a different term. And this is, in fact, and not only that, then apparently a linguistic expert, Peggy Mohan, told me that the word in Sindhi actually comes from Brahui. So it is actually a Brahui word, watau. And that watau somehow is some connection here with, a Tamil or Dravidian word here. So maybe there is more to be studied here, which hasn't been done. I mean, this idea that that the Dravidian languages were, spread all the way to the northwest and then came down, and it is, I would say that there are some, archaeological studies which do talk about the Elamite, the Iranian Neolithic farmer, the Elamites, coming down. So I think it's still not, totally. I mean, I'm not sure whether it's how, decisive or conclusive it is, but it's certainly one of the more accepted theories, I would say, at least in international scholarship.
We have two more questions, one from Piali and then.
I'll ask a gender-related question.
Yes, please.
You mentioned that archaeology and also metallurgy is also faint-hearted. And as a woman and a minority representation, so what is your experience? I mean, you worked in UK when you came back to India. So what was your experience and how did you encounter how did you project yourself?
Yeah, no, since I mentioned that trip to Agni Gundala, I still remember that when I wrote to him and said I wanted to come as Dr. Sharada Srinivasan, I wanted to come for a field trip. And then when I landed up there, he looked quite horrified because he was expecting a male. And I hadn't thought about this aspect when I wrote Dr. Sharada Srinivasan that I should specify the gender. And so he had made some arrangements and some very like something which a man would be okay with, but he realized it's not suitable for a lady. So he went into a fluster. He said, no, madam, I'll make some good arrangement and everything. So, there is, of course, that kind of preconception that, which, and I mean, I think, yeah, compared, but one aspect that I would say about, let's say, archaeological sciences is that in a way, see, women also have the ability to do things in an out of the box way because we don't maybe have that much of a pressure to conform. We don't have to be like a mainstream engineer or a mainstream whatever. We still have the room that if we want to do something different, then perhaps you could say that it's easier for a woman also to do something different because that's why there's a lot of women in the there are quite a few women, I would say, in the archaeological sciences and so on. But there are challenges even during field work, like there are some restrictions that you can't enter. Craftspeople also may say, sometimes, it may not be an overt thing, but there is this, separation of work. I mean, like it's interesting in the Kotas, who are a tribal community, that the women are potters, but the men are the blacksmiths. So you can watch the women doing the pottery and all, and no man can actually go and do pottery and all that where the women do. But on the other hand, conversely, the woman can't go and, get inside the blacksmiths, and though, of course, at other levels, the Kotas are actually, I mean, being, an indigenous community, they're actually, it's much more, let's say there's much more of equality when you look at the gender aspects compared to, let's say, some of the more mainstream, if you see some things like maybe in other parts of India, North India or something. So that's not the criterion. It's just that the functions are kind of separate. So I had to watch all of this through a window. I wasn't actually allowed to get in and take photographs from outside and things like that. So there are many, nuances which there are challenges definitely because, there is the network of, let's say, the old boys network that we always go on about. But or maybe in earlier times and so on and things like that. But to that extent, I think it's good to have recognition, like all these professional recognitions that I showed at the end, even though it's like, okay, it's a Women Engineers Award or a Women Scientists Award, it's still nice to get an award or to be appreciated. Also for these very, let's say, off the beat, out of the box or off the beat kind of areas like archaeological science, but there's no real recognition, I don't think, from there isn't any real category that recognizes it, or the other problem I have, if I have to apply for an award, there isn't a real category, like at least you scientists have an Infosys award or whatever award. There are these categories, but Nagar award, there's no real category to award us or to encourage us or whatever, so a lot of it is about personal motivation. So, and I think that becomes even more problematic, I suppose, if you're a woman, because then your access to major labs and this and that and all the rest of it it has its own, ramifications or whatever. So, yeah. Thanks.
So you mentioned about the mirror, especially the metal mirrors, and historically people have been making these mirrors, and they develop these expertise, and probably traditionally that's how this profession was passed over from generation to generation. Do you also come across instances where people also write things and then it is passed on, or it's always like this thing?
Yeah, so that's why I pointed to the Zawar example, where that is an interesting example where actually the process had been recorded in sword and Sanskrit text. But I think that a lot of it actually was passed on orally also because of, there's a lot of sense of trade secrets amongst the crafts communities. Like, for instance, even the Aranmula mirror makers, there's a lot of secretiveness because they do see it as their trade secret. And there are many, many little nuances in what they do, which they don't tell you, or it's not recorded, unfortunately. So that's why it passes, it just disappears as generational knowledge, which is a real, very sad. But I think it was also so as to be able to, kind of retain the, the monopoly or whatever to that extent. And even today, I feel guilty about mentioning the composition and so on, because, I do remember that the very first Acharya I met, Gopalakrishna, he was saying that nobody knows the composition and nobody can find out and this and that. So, there is that aspect of some of the secrets which they don't want everything to be unpacked or somebody to replicate it and all the rest of it. That's it.
Okay, so let's, maybe in the interest of time, we will move to the next session and maybe you can discuss with her over tea. Yeah, so let's thank the speaker again for a very interesting talk. Very questions for you. Now I welcome our Dean, Professor Shivani, to give a memento to our speaker as a token of appreciation.
Observatory and oh, fantastic. Thank you so much. Oh, thank you. Thank you so much. Very nice talk. Thank you.
Yeah.
I'm sorry if I went on and on with this. I think it was really interesting. It's hard always to time things.
Finally, I welcome Pialu to go the stands and then we can. Yeah, please don't go away because it's a group photograph and then refreshment. So we basically are holding you up for that. So, yeah. So first of all, thanks to Professor Sharada Srinivasan for a very enlightening talk. So we came to know how much metallurgy and astronomy are actually, entwined. So, so actually when we were, WGG was looking to organize this Annamani lectures, we were looking at various places. And after some initial failures, we thought we'll look back home. And I asked Dr. Smita Subramanian, who is the chair of the Gender Amity Cell in IIA, if she would like to, help us organize this. And she was very excited and, take up on the responsibility. So I thank her specially. And I also thank our dean and the director for extending all the encouragement to organize this event here. And I also thank the director's office for logistics support and the gifts. Yogesh for support in the auditorium and the photographs he's taking. And special thanks to Scope and especially Vikrant for the YouTube live, help with the YouTube live. I also thank the transport desk and the canteen for organizing the transport for the speaker and the lunch and the high tea. And I also finally, I thank ASI and IIA for financial support. And of course, to all of you for taking time out of your busy schedule to attend this talk. So I hope I haven't missed anyone. So yeah, with that, I think we can take the photograph here only, Yogesh, right? We have not very many people left. So.
But Yogesh can put it back later.